Okay, I am recording. I'm going to talk about elastic collisions. Elastic collisions. Well, let's see. What is an elastic collision? Well, it's collision. First of all, kinetic energy is conserved. All right. And then, of course, that's basically it. In an elastic collision, kinetic energy is conserved. That means that the total kinetic energy before the collision is the same as the total kinetic energy after the collision. So now momentum is always conserved during any kind of a collision, right? So then we can classify two other types of collisions besides elastic, depending whether or not kinetic energy is conserved. So then there's a kind of a collision called an inelastic collision. In an inelastic collision, kinetic energy is not conserved. Right? That means that the total kinetic energy before the collision is actually going to be greater than the total kinetic energy after the collision. Yeah, and that energy ends up being transformed into sound or heat, right? When these objects bang against each other, they might change shape. Again, linear momentum is conserved in all of these types of collisions. So the other thing that distinguishes between these two types of collisions, and then the third type of collision is whether they bounce or stick, right? So then you have a third type of collision called a perfectly inelastic collision. Yeah, so kinetic energy is not conserved. Again, that means the total kinetic energy. And I'm using a K and an E here so you don't get confused with spring constant K. So the total kinetic energy initially is still going to be greater than the total kinetic energy after the collision. And then what's also going to be true here is that this kind of a collision is a sticky collision. They stick together after the collision. Right. So a perfectly inelastic collision is sticky. An inelastic collision, that's bouncy. They don't stick, but kinetic energy is not conserved. And also a elastic collision is bouncy as well. All right. So now, let me give you some examples of all three types of collisions here. Although all the problems we've been doing here pretty much are where they stick together, we've been doing a bunch of those. Those are all perfectly inelastic collisions. And as you know, we've calculated kinetic energy before and after, and it's always less afterwards. Right, so now let's look at a way to distinguish between these two types of collisions up here. Okay, so let's drop some balls. Let me put a grid. All right, so I'm going to do some collisions here by dropping something on the ground. Okay, and so let's say that this first one is demonstrates it's bouncy. right? And then also we're going to say that kinetic energy is conserved. So this is essentially going to be like an elastic collision. All right, so I'm going to drop something here. I'm going to release this ball from rest, right? All right, so V naught is equal to 0 meters per second. And we're going to drop it, and it's going to collide with the Earth. All right. So in this collision, this little red ball is one object, and the Earth is the other object. All right. So it's going to fall down. It's going to bloop, hit the ground here. It's going to bounce back up. And let's say that when it bounces back up, it bounces back up all the way to its original position. Okay. Which you won't see happening in reality, because there's always a little bit of loss of kinetic energy when you drop pretty much any object, right? It could be really, really bouncy, almost go back up to the same position, but not entirely to the same position, right? So there's always a little loss. If the collision was elastic, yeah, if we had an elastic collision between a super duper super ball and a table, it would bounce back up to the same height. So this is what an elastic collision might look like, right? No loss of kinetic energy. Then let's look at an inelastic collision. Okay, so keep in mind, this collision is also bouncy, but it's not super perfectly bouncy. So this is the type of collision we observe when we drop something, all right? So let's drop another little ball right here. Okay, and so again, V naught is equal to 0 meters per second. And it's going to bloop, it's going to hit the ground, and it's going to bounce back up. Uh-oh, it doesn't bounce back up to the same position, right? It's going to stop right here, for example. Right, so that tells you that it's bouncy, but it's not perfectly bouncy, right? So kinetic energy is not conserved in this second type of collision. If kinetic energy was conserved, it would bounce back up to the initial height, right? And then finally, the third type of collision here is perfectly inelastic. Right? Sticky collision. And that would be, for example, like dropping a lump of clay onto a table. All right, so here's your lump of clay, just for example. All right, so it's going to start off at rest here. And we let it go, and it just splats and sticks. It stops right there. Right. So there's 3 different examples showing you one way of looking at differences between these types of collisions. Right? Bouncy and perfectly bouncy, that's called an elastic collision. Kinetic energy is conserved. Inelastic, kinetic energy is not conserved, although it's bouncy. And then finally, a perfectly inelastic collision, kinetic energy is not conserved, and it's not bouncy. It's the sad little ball right here. He's lost the will to bounce. Anyway, so that's it for describing these types of collisions. Thank you very much.